In this lesson, we'll finish off learning target number 6, focusing on completing the step of identifying a molecular compound by determining its molecular formula. Finding the molecular formula is the last step in identifying an unknown molecular compound. Remember that the empirical formula is just the molecular formula reduced into lowest terms. If you can figure out by what factor the empirical formula was reduced by, you can just reverse the process and identify the compound. If you know the empirical formula for the compound, add steps 6 and 7 onto your method. If you're given percent composition information or CH analyzer or hydrated ionic compound experimental data, you will have to do step 1 to 5 in order to complete the question as well. In order to find the molecular multiplier, which is what the empirical formula was reduced by, you take the molar mass of the original compound and divide it by the molar mass of your empirical formula. The molar mass of an unknown substance can be found by using a piece of equipment known as a mass spectrometer. You can review on page 281 at how this machine works. Remember, this is also how different isotopes of elements are identified and their abundances are determined. Example 1 shows you how steps 6 and 7 of the method work. A compound with the empirical formula of CH has a molar mass of 39.06 grams per mole, probably determined using a mass spec. Step 6 says find the molecular multiplier. By taking the molar mass of the real compound and divide it by how much your empirical formula weighs. If I add together the mass of a carbon and a hydrogen, I get 13.02 grams per mole. That means the multiplier is 3. Now multiplier should always work out to be extremely close to a whole number. You may need to round it a little bit, but you should never have to multiply by 2 to 6 in order to get a whole number at this step. If this doesn't happen in your question, it means that there's a problem when you determined your empirical formula. Go back and check over your calculations for this. Step 7 of the method says multiply the empirical formula by the molecular multiplier. This is where I like to include ones in my empirical formula on elements that only have single atoms. That reminds me to times each of the elements by 3. The real compound is C3H3 in example 1. Example 2 makes you go through the whole process, starting with some percent composition data. Pause the video here and try the question out on your own. Here's the answer for example 2. Because I've given percent composition information, I'm going to achieve step 1 of the method by taking a 100-gram sample. That will allow me to take the percent mass of each of the elements and change the units into grams. Step 2, change these into moles by dividing by the molar masses. Step number 3, divide by the lowest number. That comes from oxygen. Carbon works out to 2. I can round that one. But my hydrogen works out to 3.36. I can't round that. Oxygen works out to 1. 0.36 is pretty close to 0.33, or a third, so I need to multiply by 3 in order to get whole numbers to achieve step 4. That gives me the empirical formula C6H10O3. Step 6, I determine the molecular multiplier by taking the molar mass of the unknown compound, which is given to us in the question, 390.48 grams per mole, and I divide that by how much my empirical formula weighs. A C6H10O3 has a molar mass of 130.16 grams per mole. That gives me a multiplier of 3. For step 7, I take my empirical formula and times it by my multiplier. That gives me a molecular formula of C18H30O9, and I have now identified the unknown molecular compound. For your assignment, there are some textbook questions listed on the assignment cover sheet, as well as question 9 and 10 from the worksheet you used during the Finding Formulas by Experiment lesson.